Hi. Today what we're going to be talk about is one of our subscriber request is VFD control wiring using our pressure transmitter. So so recently I have received many commands about VFD control wiring. So that we're going to be explore about more. Today I took the pump application drawing using our pressure transmitter. So VFD pump application wiring diagram, and mainly we're going to be focus three-phase power input to the VFD, which is switched from MCCB or MCB or isolator, that depends upon the application requirement. And input side also we need some necessary protection that we need to ensure while connecting the three-phase input to the VFD, and the three-phase power output to the motor with the respective of protection like overcurrent, short circuit, like that will be ensured by the VFD. And the digital command, how should be the digital command, that we going to be explore, and the analog command for the speed, that also, and for the fault. These are the main 5 things for the pump application wiring. See, generally knows, based on the application, wiring can be differ for the power circuit also and the control circuit also. So that we need to ensure you guys are mainly focus which application, what kind of wiring we going to be do, that we need to confirm while selecting the application and while selecting the BFT. Okay. So this is a VFT, typical VFT power and control diagram for the pump application. So VFT inputs for the three-phase come from the MCCB. This is the input side. There are protection available for the overcurrent and short circuit provided by MCCB, and for the outputs from the VFT UVW terminal directly connected to the motor. You can see directly connected to the motor. So output side of protection is, there are many protection available in output side, that is ensured by the VFT, like overcurrent, over voltage, short circuit, base loss. There are several protection available from the VFT. So this is the power diagram of VFT. And the control, see, generally everybody knows, based on the application, power and control wiring can be differ. So today we have made for the pump application. So based on the pump application, control wiring I have made. So in control wiring there are two terminal group, one is for the digital and the another one is for analog. These two group, you can see all manufacturer VFDs like ABB, Siemens, whatever VFD manufacturer brand, you can see these two group of terminals, digital and analog. So for the pump application, digital why we are using to receive the run command, to receive the stop command, and is there any emergency command in the field, that also we can enable through the digital. So for the pump application, start stop, actually VFD run command, it's come from pressure switch. Pressure switch, when it is reached the set point, it became a NO to stop the motor, and when it became a low set point, it became a NO to stop the motor. And when is pressure switch is below the set point, it became a NC to maintain the run command. So these are the digital, and is for the emergency, we have connected to the DI01. Emergency is, we can use as a like emergency push button as a digital command. We can install in the field nearly pump section. Is there any over noise or any damage in the pipeline, we can give the emergency command to stop the motor from the field. And the okay, this is digital for, we receive the run command from the field to run the motor, but at which speed need to run the motor, what hertz we need to run the motor, that will determine by the analog terminals. So for the pump application, see here, this is the reference. Generally the reference will be a 5 volt or 10 volt, that determined by the VFD manufacturer. So we have, there are two inputs, one is for the AI1 and one is for the AI2, and this is for the common. So AI1 we used for the set point and AI2 we used for the feedback. So set point, you obviously know for the pump application, they generally maintain the bar 5 bar or 7 bar, 8 bar, 10 bar. Based on their requirement, they will maintain the set bars. So we can, for the AA1, we can set the set point as a 5 bar, and based on the feedback connected to the AA2, it comes from the pressure transducer which is installed in the pipeline of pump application. So based on the feedback, motor will run until achieve the set point of the set bars. So once the set point is received, motor can be going to the stop mode. Once it below the set point, motor still running, still maintain the running to achieve the set points. So wiring will be like that only. So here you can see AA1 for the set point and AA2 for the analog feedback. So voltage source is 0 to 10 volt DC. And this for, and here you can see one of the other major control circuits, that is relay outputs, digital outputs. See, generally every VFD manufacturer maintain the output relays, like 2 relays, 3 relays, like that, based on the VFD capacity and application requirements. So here you can see the one digital outputs, common NONC. This we used to for, there are several functions is there that we can enable through the parameters, but generally we use for the run. Once VFD started run, we can use as a feedback, and once VFD is fault condition, we can use as a feedback. So here we used for the one common MCB for the control circuit that will directly be connected to the relay common, and NO. When is this relay we used for the trip, VFD trip fault condition? When VFD become a fault mode or fault condition, this relay can be enabled through the VFD. So using of this circuit, we can stop the control circuit to ensure the safety of the motor. So these are the pump application VFD wiring. There are many wirings can be differ based on the application requirement. So this is the general pump application we have made for the drawing, control and power diagrams. So okay, is there any doubt or need more clarification about this diagram? You can comment me, or you need a diagram or control circuit of any other application, any other devices, just let me know in the comment.